In this mini lecture, we're doing a couple of examples on using implicit differentiation. So our example given is going to be x squared plus y squared equaling 9. Now, if we were to solve this for y and put this in a more explicit format, then we would see we would get y is equal to plus or minus. So that won't work for us in finding the derivative. So what we'll do is go ahead and use our skills in implicit differentiation. So we're going to take the derivative of each of these terms. So the derivative of x squared, and then we'll take the derivative of y squared, and the derivative of 9. So we're taking the derivative of all of these with respect to x. So in this first term, it's no problem. The derivative of x squared with respect to x, we can just use the power rule. So we'll say it's 2x. However, in the second part, that's where we apply our implicit differentiation technique, where we say, okay, we have the derivative of y squared with respect to x. However, that variable y is not what we're taking the derivative with respect to. So we're going to apply that chain rule that we've learned and say, okay, the derivative of the outer, we'll apply that power rule, which is part of the chain rule, which say it's 2 times y as the inner stays the same. And then we're going to multiply it times the derivative of the inner. Well, the derivative of y with respect to x is dy dx. And then, of course, for the last term, we know that the derivative of any constant is just 0. Okay, so in the next step, after you've taken the derivative of all of the terms in your problem, then you'll solve for dy dx. So to solve for dy dx, we need to get the 2y dy dx by itself first. So that would tell us to move the 2x to the other side. So we'll subtract 2x from both sides. All right, and now between 2y and dy dx, we know to be multiplication, so we do the opposite, which is division. So we can now say dy dx is equal to negative 2x over 2y. All right, and then lastly, we can clean it up a bit and say to ourselves dy dx is equal to 2's will cancel, negative x over y. So our next problem says to differentiate x to the third y to the fifth plus 3x is equal to 8y to the third plus 1. So for this one, we have to take a close look at that part right there. That's going to involve us doing something a little bit extra. So now what I'm going to do is just show what we're doing, right? We're going to do implicit differentiation, but we're going to take the derivative is what I want to show of each of these. So we're going to take the derivative of x to the third, y to the fifth, and then take the derivative with respect to x of 3x, and that's equal to taking the derivative of 8y to the third, and then we're going to take the derivative with respect to x of 1. So with that next part, we see x to the third, y to the fifth. Those are two different functions. You can call x to the third your f and y to the fifth your g, and therefore, and that's why I wrote it at the top right here, we're going to have to apply the product rule to that. So we apply the product rule to taking the derivative of x to the third, y to the fifth. Okay, so the product rule says take the derivative of your first function, that f function. So the derivative of x to the third with respect to the x is 3x to the second. And it says to multiply it times your second function without doing anything to it. So we multiply it times y to the fifth. And then the product rule, so we're still in the product rule, we haven't moved on to the next term. The product rule says then take the derivative, take that first function, which is x to the third, we'll write it over, and then take the derivative of the second function, which is y to the fifth. Notice that the y is not what we're taking the derivative with respect to, so we apply our skills in implicit differentiation using the chain rule, and that becomes 5, the derivative outer, and that's y to the fourth because the inner stays the same. and then we're multiplying times the derivative of the inner, which is the y. So that's just going to be dy dx. And some people can choose to use just y prime, which is totally fine. So now we've just completed that first term. Now we go on to the next one, the derivative of 3x with respect to x, no problem there, is just 3. The derivative here of 8y to the third. So on this one, we take a look at that. The 8 can be pulled out as the coefficient, so we can take the derivative of y to the third. However, see the y, it's not the variable that we're taking the derivative with respect to, right? So we're going to use our chain rule. So that'll be 3y to the second times the 8 makes it a 24y to the second, right? And then you have to multiply it times the derivative of the inner, which is dy dx, all right? And then the derivative of 1 of any constant is 0, and I don't need to write that. Okay, so now I just rewrote that line above without the dots, and I put the 5 to the front of everything there. So just be a little bit careful here because things get a little messy with the algebra. So now all we want to do is put the dy dx's on one side and everything else on the other side. So we'll have 5x cubed y to the fourth dy dx, and we'll have the negative 24 y squared dy dx, right? All of that on one side with everything else on the other side. So we're going to have to put the 3x squared y to the fifth on the other side and that 3 on the other side. So when we move them to the other side, we have to change the signs to negative. All right, so in our next step, we have the dy dx's on the left, so we just need one of them because we're solving for that. So we're just going to factor it out as a GCF. So dy dx factors out, and it goes into 5x cubed y to the fourth dy dx, 5x cubed y to the fourth times, and it goes into negative 24y squared dy dx, negative 24y squared times. And then this is just equal to the other side. All right, and then the next thing we do is just say to ourselves, how do we get to dy dx by itself? Well, between that and what's in parentheses is multiplication, so we'll just divide both sides by 5x cubed y to the fourth minus 24y squared. So once we do that division, we should get on the other side negative 3x squared y to the fifth minus 3 all over that 5x cubed y to the fourth minus 24y squared. So again, just take your time and be careful with doing everything slowly and correctly.